Okay, slide can, no problem. Okay, good afternoon. Okay, today we are connecting everything from the particle to the property. So from here, by the end of this lesson, I want everybody's understand how the tiny particle we cannot see explain about the melting point, conductivity, bonding, and regarding all these very important. Okay, the exam questions. And this topic form the foundation for many chemistry questions. So mastering this topic is very important and it will make many latest topic easier a bit for you. Okay. So this one, let's begin for the three state of the matter. So in solid, okay, this is a solid state. Particles, we can say that they are very close to each other and touching in a regular arrangement and they vibrate only. So in the liquid, okay, particles are still touching, but they arrange randomly and can move past each other randomly. Be careful. You see the key point, randomly. Okay, in gases, particles are far apart and move randomly and quick in all directions. So in the exam, you must always mention the three things. Particle spacing, right? It means the particle separation. Arrangement and the movement, the motion. So this is the three major points you need to remember. Okay, next, energy and change, decoding the cooling curve. So this curve, this kind of line is very important. So from here, you can see that the line will go down, horizontal, go down, horizontal again, and moving down. Okay. So from here, as shown in the cooling curve diagram, temperature decreases as the particle lost the kinetic energy. So, however, we need to notice the flat sections. Flat section for this part, horizontal line. Okay, that is during the condensation and freezing. Temperature remains constant because energy is being used to form the force of attraction between the particle instead of the lowering temperature. So from here, you need to know that constant temperature means constant temperature means kinetic energy stay constant, whilst potential energy changes. So I want to highlight again. From here, you can see that the gas cooling down, kinetic energy decreases as the temperature drop. Okay, horizontal condensing, temperature constant, key point. Temperature constant at the moment is energy used to form the forces of attraction. So at this moment, kinetic energy constant. Okay, potential energy changes. Then at this point, this common point actually is supposed to be this point in this intersection point is the gas and the liquid status. Is we call condensation point for this temperature. And when you're going down, kinetic energy decreases as temperature drop. Is cooling process, right? Cooling, liquid cooling. So come to the freezing. Temperature constant again. So energy used to form the forces of attraction, telling us what the potential energy is changing in this stage. Then at this point is the freezing point, liquid plus solid together. Then all the way down, it becomes the solid cooling. Okay, solid cooling. Sublimations, right? You need to know that it's a direct change from solid to gas. This is the very special. Okay, for there's one of the very special case. So if let's say solid directly to gas, okay, what kind of the example? Dry ice. Okay, dry ice. Actually, what is a dry ice? Okay, dry ice is the CO2, carbon dioxide. Okay, it's a carbon dioxide. Okay, next, Brownian's motion and diffusions. The diagram shows the Brownian's motion, smoke particle. Okay, the enlarged view for you, microscope view. Moving randomly because they are hit by invisible air molecules. And this proves particles are always moving. So the small particle move randomly, hit by invisible, fast-moving air molecules. This statement very important. So on the right, you can see that diffusion is shown using the this kind of the bromines and chlorine gas, right? So from here, chlorine diffuse faster because it is lighter. You can see that the gas jars, right, inside we have the heavy reddish brown gas, and chlorine compare is lighter, and this green color gas easy for you to is easy to see lah. Okay, so from here, uh, we can see that the example at the same temperature, we can come up with the conclusion is under the same temperature. Okay, under the same temperature, the light particle diffuse faster. So you can see lighter particle is a chlorine diffuse faster than the heavier one, bromine, at the same temperature. Okay, so this is the very important statement you need to jot down. So bromines compared to chlorines, heavy versus the light reddish brown gas to the green gas. Okay, next part, subatomic structure. Okay, we have the proton, we have the neutron, we have the electron. Relative charge is +1, neutron is 0, electron is -1. So you can see proton and neutron is at the center point. Relative mass, this is a ratio number lah. Okay, so proton, let's say, is 1 unit, neutron is 1 unit. Okay, then electron is very light, very small. Okay, electron, you can imagine that is a piece of proton or neutron divided into the 1,840 pieces. Understand? So the electron is very small. So from here we can see that proton has the +1 charge and are found in the nucleus, right? And that neutrons has no charge. We said 0 and are also in the nucleus. Nucleus is in the middle position. And then electron have the -1 charge and move in shells around the nucleus. So we actually, for the chemistry reaction, we always dealing with this kind of reaction is involving the electrons, right? Not proton or electrons. So means that chemical reaction can happen due to electron, due to electron. Okay, so it's very important for this. Next, the numbers game, calculating particles. So you can see that this kind of the thing, right? Then the elements and the number on top and then at the bottom. So today onwards, if you still cannot remember, please jot down and remember. Okay, neutrons actually is equal to the nucleus number minus the proton number. So means 37 lah. Example, you see this 37 and 17. 17 actually means the electrons number, right? Electrons number, or you can see that electrons number, right? Then 37 minus 17 equal to 20. 20 is neutron. Neutron is this part inside information. This one you minus this one, you do the calculation, you get 20. Because this 37 actually is the proton plus neutron number together. Okay, so this 17 actually can tell us two information. It's equal to the number of proton. Also, we can know that it's equal to the number of electron. Okay, for the neutron status lah. So 17, we know that is proton. We also can understand that for this element, got 17 of the elements. But for this case, you see that the question give it to you 1 minus. You see that this 1 minus means what? Is the ion charge. Ion charge, it never write any number with default is 1. Okay, it's -1, -1. So -1 for this case, right? You got 17 of the electrons under the neutral status, plus 1 more, right? Plus 1 more electrons. So for this case, we got 18 electrons in for this scenario. And then the nucleus number, actually, this 37, you can understand is a mass also. It's a mass, okay? It's a mass. It's a so-called the neutron number. So the nucleus number, remember, is the proton number plus neutrons number. Okay, so in order for you to find out the neutrons number, what you need to do, you need to do the calculations. 37 minus 17 equal 20. Okay, equal 20. So for this case, the negative means is the negative charge. Okay, next, isotope. And this topic, isotope, is very important concept. What is called an isotope? Example for this case, right? Why do they have the same chemical property? Question was asked. So you need to show the key point. It means that they have the same electronic structure. So example for this one is show the isotopes of the magnesium. And they have the different number of neutrons and so different masses. Right, but they have the same number of electrons, so they have behave chemically the same. So I repeat again, you see, direct 24 and 25, and then the outside the orbit for this surrounding actually is electron. So you see the electron, right? They have the same number of electron, means same electronic structure. So behave chemically the same. Okay, we have chemical the same. So the isotope only difference is what is the number of the p proton. Okay, next classification. Elements, compound, and mixture. Element, remember, it just refer to one type of atom. Compound is bonded in the fixed ratio. Mixture, right, is a physically mixed but not bonded. Okay, not bonded. So elements, always we say that contain one type of atom. Compound is key point, chemically bonded in a fixed ratio. Okay, example like CO2, H2O. This kind is called compound. Mixtures are physically mixed and can be separate physically. So it's like just normal mix together. Excuse me. So it's a water and oil, right? Water and oil. After that, you separate. You still can get the water and oil itself. Okay, next. Ionic bonding. Okay, ionic bonding, from here we can see that magnesium fluoride. Okay, key point. Listen carefully. Ionic bonding, right, is the electrons are transferred from metals to non-metal. I repeat again, ionic bonding related with metal and non-metal. Okay, so magnesium lose the 2 electrons to fluorines, forming the, you see that magnesium atom, right, with the fluorine atoms. So if lose for the 2 electron go to the fluorines, it itself become 2 plus from here. And then we know that the fluoride ion, each of them get 1 electron, become -1, -1. Okay, so from here, strong electrostatic attractions between the oppositely charged ions. Okay, so it becomes the magnesium fluoride. Okay, so these oppositely charged ions attract strongly. They can form a giant ionic lattice. Example, covalence bonding, another very important concept. Covalence means what? Is regarding two non-matter. I repeat again, two non-matters is referred to covalence bonding. Okay, in covalence bonding, non-matters share the electrons. So the diagram show the carbonyl fluoride, right? COF2, carbon, oxygen, fluorines, fluoride, right? Okay, fluorides. So the fluorines are where the atoms share the electron to achieve stable outer shells. You can see that they become the very steady structure. So remember, covalent bonds are strong within the molecules. So metal and metal, they together sharing for stability structure. Okay, next, simple and giant covalent. So covalent itself can divide it into the 2 types, simple structure and very big giant structure. Simple covalent molecule have the weak intermolecular force. So they have the low melting point. Key point, weak intermolecular force, low melting point. And then the giant structure like diamond, they have the strong covalent bonds, key point, and they have the high melting point. So this is just one of the example for you. You can see. right? One is very high, 1710 degree, and this is minus 69, low. So I repeat again, simple molecule, low, and this one, giant covalence, have the high melting point. And then the force in between is the weak intermolecular force and the strong covalent bond. Okay, now we go to the next one. Metallic bonding, the C of electrons. So you imagine that this is a structure, right? Magnesium's metal bro. Let's say this is the magnesium's atom. Okay, so electrons are free to move and carry charge, go through the structure. Okay, and imagine that the blue color one is like the C. C of what? C of the localized electron. The localized electron means that the atom free to move around. Okay, so from here, this gray ball you can imagine is a positive ions Mg2 plus. Okay, and this one positive ion, the deep charcoals inside in structures, right? Layers like over each other. Okay, so from here we can see that uh the metallic bonding positive ions surrounded right by the C of the localized of the electron. Okay, moment let me move out this one. Okay, so the free electron explain why the metals conduct electricity and heat. Okay, so explain about this. And then the sliding layers, right? Explain about the malleability. Okay, so here from here we can see a few terms. Okay, you can see the few concept. First concept, right? You can see that is first thing, free electrons, right? Explain why the metal conduct electricity and heat, and then the malleabilities, right? Is means that the layers slide over with each other, the sliding layer. Okay, it can use to explain by using the reason of the sliding layers. So for this malleability. Okay, next, property showdown. So from here, this is a very important summary. The table show how the bonding affects property, right? Where the metals conduct in the solid and liquid state. Okay, so the melting is high, conduct for the is a yes for the electricity, right? Conduct in liquid, yes. Ionic, okay. Ionic compounds conduct only when the molten or dissolved, because ion must be able to move. So from here, conductivity under the solid is no. For the liquid, right? Okay, very important. Crucial exam point for you is yes. Melting is high. Giant covalence, right? Substance do not conduct. No, cannot conduct electricity, right? And this is very high melting point. Simple covalence, right? Have the low melting point and do not conduct. Do not conduct. Okay, do not conduct. Okay, so from here, substance G, E, F, D. Let's say from here, exams always give it to you the property and ask you to identify bonding the type. So if the question is said that, okay, is conduct when solid, okay, we understand that that must be a metal, right? Conduct only when liquid, only for liquid status. Okay, so most likely for this is an ionic. And let's say does not conduct, right, and low melting point, low melting MP, melting point never conducts, right? Then you can come up conclusion. It must be the simple covalent. Very high temperature, very high melting point and no conduction at all. Must be the giant covalence. That you see the diamond structure. Okay. Okay. So from here, come out a summary for the critical exam concept. Okay, for the very important first part. So solid vibrate only, liquid and gas move randomly. Okay, and isotopes have the identical chemical property because they have the same electron configuration. Ionic compounds cannot conduct electricity as solid, right? Because ions are fixed in the lattice. Lighter molecules diffuse faster than heaviest one at the same temperature. And the simple molecule have the low melting points due to the weak intermolecular force. Giant structure have the high melting points due to the strong covalent bonds. So all this question actually is a prediction, okay, for the coming Igcse chemistry. So for this part is a theory part, okay, for the state of matter, atoms, element, and compounds topic. So from here, questions 1, state of matters. Define the term of sublimation, and a substance is cooled from gas to solid, right? Describe how the particle arrangement changes during the condensation and explain why the temperature remains constant during the freezing. Brownian's motion is observed when the small particles are viewed under a microscope. So what caused Brownian's motion, and explain why increasing temperature increases the rate of Brownian's motion. Okay, so this is the very first question. So from here, you can say that for the answer, it's a change of the state in which a solid changes directly into a gas without passing through the liquid state. This is a basic definition. So I really hope you guys, right, can try to memorize it. Okay, can try to memorize. Next. The question asks you to describe particle arrangement change, right, during the condensation. So you can say during condensation, the particle move close together and becomes more regularly arranged compared to the gas state. So the particle lose energy and the movement become less random. Okay. Next, the questions. Explain why the temperature remain constant during the freezing. Then you can say remains constant, right? Is during the freezing because the energy is released as a latent heat, whilst the bonds are formed between the particle. So the energy change is used for the change of state rather than lowering the temperature. Key point, I repeat again, released as latent heat. Okay, bonds are formed between the particle. Energy change is used for the change of state rather than lowering the temperature. This is very important key point. Okay. Next, Brownian's motion is observed when the small particles are viewed under a microscope. So what causes the Brownian's motion? You can say that Brownian motion is caused by random collisions between the small particle and the fast-moving air molecules. Must be able to use the proper language to provide the complete answer. And explain why increasing temperature increase the rate of Brownian's motion. Then you can say increase the temperature, right? Increasing temperature increases the kinetic energy of air molecules, causing them to move faster and collide more frequently and forcefully with the small particle. Okay, so far is it all right, student? Get the point? Okay, next question number 2. Okay, for you, questions number 2. Diffusion. Okay, regarding diffusion, chlorine gas move faster than Bromine gas. What is Brownian's motion? Brownian's motion, actually just now you can see our previous, okay, the student asked about this. A moment. Okay. Now, it's called this Brownian's motion. Right. It's a one kind of the motion, small particle. Okay. Brownian's actually is the Mr. Brown. Mr. Brown is a scientist name. Right. One day he smoked, right? Okay, and then he collect the small particle, put inside, okay, a container, then use the microscope. Okay, under the microscope, he observed the smoke movement. he found that how come the smoke can like move around very fast? Okay, this kind of action is called this kind of motion is called Brownian motion. Then Brownian motion telling us what? Small particle, you know the people smoke, right? You can see the smoke. Yeah, because small particle is bigger a bit. A molecules, A particle, not easy to see because very small. Okay, so you cannot see the oxygen, right? You cannot see the carbon dioxide. You cannot see the nitrogen gas, but you can see the smoke. Okay, so they found that small particle move randomly. Then conclusion is they are hit by the invisible A. So is it okay? I explain to you Brownian's motion, student. Yes or no? Okay, now I continue. Regarding diffusions, right? Use data from the periodic table to explain why. Then after that, describe one experiment. Ask you to demonstrate the diffusion in liquid. So this kind of questions very important. Diffusion, that is a, we call it what? Is a definitions, right? So you just memorize it. It's a net movement of particle from a region of higher concentration to a region of the lower concentration due to random motion. And then the chlorine gas diffuse faster, right? Because it has a lower relative molecular mass. Please use the chemistry term to explain. Lower relative molecular mass, right, than bromine gas. So the lighter molecules move faster at the same temperature. At the same temperature. Yeah, it means that it is lighter, but in order to score the full mark, right? Okay. You have to use the term lower relative molecular mass. So the bromines, right? Bromines, that one is heavier a bit. Chlorine is lighter. Okay. Next question asks you to set up one experiment. You can see I use a crystal of potassium manganate, right? Can be placed in the water. Over time, the purple color spread through the water without stealing, without any disturb of the water. It will just itself happen. So showing diffusion, very simple experience, right? Very simple experiment, I mean. Okay, so this kind of experiment, you can memorize it. In exam, maybe we'll ask you to set up one experiment to explain. Okay, so this is the prediction we provide for you. Next question. So magnesium is represented as the 24 and 12 mg. Question from here asks you to do the basic calculation. Proton, neutron, electron, and when you come up for the Mg2 plus ions, right? Explain how the 2 plus is formed. Question asks you to explain and state the electronic structure of Mg2 plus. So from here you can see that we do the calculations. 24 and 12. We know that 12 means 12 electron. 12 proton. Then the neutron, we use 24 minus 12. Okay, we use the minus 24 minus 12. Normal, simple calculations. Okay, so from here, let me write down for you. This is the 24, right, minus 12. So equal to 12. Be careful, this 12 is referred to the neutron. Okay, and this bottom actually telling us there's a 12 electron and 12 proton. That's it. Okay, and then question asks you the Mg2 plus how is formed. Then you can say that magnesium's atom loses the 2 electron from its outer shell. Key point, you lose the electron. Then you yourself is not neutral anymore, right? So you become 2 plus. Okay, and then the question asks you to write the electronic structures for this one. Okay, so from here, at complete the MCQ already, and very good. The result is well done. Just a few mistakes. Okay, let's see question number 3. Diffusions occurs because of the particles. Your answer give it to me. No, actually it's supposed to be move randomly. Move randomly. Answer is B. Diffusions occurs because a particle move randomly, spreading from the high concentrations to the low concentration. right? It is not caused by gravity or any attraction. So answer is B for boy. Okay. Number 4, you made the mistake. Number 4, which gas diffuse fastest at the same temperature? Answer is C. We need to refer to molar mass lah. Molar mass. For example, hydrogen gas H2 is H equal to 1 times 2 equal to 2, right? CO2, you go to refer periodic table, you will get 44. Cl2, you can get 71. Br2, we can get 160. So from here, lightest one must be the hydrogen. Answer is C. Okay? Okay, number 8, you made a mistake for questions number 8. Questions number 8 from here, isotope of the same elements have what? Different number of neutrons. I told you already. Isotope, neutron number not the same. N number, the N itself. N stands for neutrons, right? Different number. They have the same number of protons but different number of neutrons. So this changes, right? This changes the mass but not chemical property lah. Okay. Number 10. Number 10. Sodium chloride conduct electricity when molten because we said B. Ions are free to move. Remember, as long as can conduct electricity, must be have the ion free to move around and carry the charge. That's the reason. So the electron do not move freely in ionic compound. Okay, so answer is B. Okay, 14. Okay, 14, metallic bonding consists of metallic bonding, positive ion and delocalized electron. Answer is B. Metallic bonding consists of positive metals ion, right? Surrounded by the delocalized electron. So this electron move freely. That's why answer is B for boy. Your answer give it to me, donkey, is not correct. 17.